Today, I want to talk to you about 3 ways we can look for evidence of alien technological civilizations. The first way is to look for deliberate attempts by them to communicate with us, like through radio broadcasts. The second way is to look for signs that they've visited our solar system. And the third way is to look for evidence of large-scale engineering projects in space. A team of astronomers has taken this third approach by examining recent astronomical survey data to identify 7 potential candidates for alien megastructures, known as Dyson spheres, that are deserving of further analysis. Their research was published in the journal Monthly Notices of the Royal Astronomical Society. This is a detailed study looking for oddballs among stars, objects that might be alien megastructures. However, the authors are careful not to make any overblown claims. The 7 objects, all located within 1,000 light-years of Earth, are M dwarfs, a class of stars that are smaller and less bright than the Sun. Dyson spheres were first proposed by the physicist Freeman Dyson in 1960 as a way for an advanced civilization to harness a star's power. Consisting of floating power collectors, factories, and habitats, they'd eventually surround the entire star like a sphere. What Dyson realized is that these megastructures would have an observable signature. Dyson's signature, which the team searched for in the recent study, is a significant excess of infrared radiation. This is because megastructures would absorb visible light from the star, but wouldn't be able to use all of it, so they'd have to dump the excess energy as infrared light. Unfortunately, such light can also be a signature of many other things, like a disk of gas and dust, or disks of comets and other debris. But the 7 promising candidates don't fit well with disk models, so they might be something else. It's worth noting that there's another signature of Dyson spheres. Visible light from the star dips as the megastructure passes in front of it. This kind of signature was found before with Tabby's star, KIC 8462852, which showed many unusual dips in its light that could be due to an alien megastructure. It almost certainly isn't an alien megastructure. A variety of natural explanations have been proposed, such as clouds of comets passing through a dust cloud. But it's still an odd observation. An obvious follow-up on the 7 candidates would be to look for this signature as well. The case against Dyson spheres. Dyson spheres may well not even exist, though. Personally, I think they're unlikely to be there. That's not to say they couldn't exist, but rather that any civilization capable of building them probably wouldn't need to, unless it was some mega art project. Dyson's reasoning for considering such megastructures assumed that advanced civilizations would have vast power requirements. Around the same time, astronomer Nikolai Kardashev proposed a scale to rate the advancement of civilizations, based almost entirely on their power consumption. In the 1960s, this sort of made sense. Looking back over history, humanity had just kept exponentially increasing its power use as technology advanced and the population grew, so they just extrapolated this ever-expanding need into the future. However, our global energy use has started to grow much more slowly over the past 50 years, and especially over the last decade. What's more, Dyson and Kardashev never specified what these vast levels of power would be used for. They just, fairly reasonably, assumed they'd be needed to do whatever it is that advanced alien civilizations do. But as we now look ahead to future technologies, we see efficiency, miniaturization, and nanotechnologies promise vastly lower power use. The performance per watt of pretty much all technologies is constantly improving. A quick calculation reveals that if we wanted to collect 10% of the sun's energy at the distance the Earth is from the sun, we'd need a surface area equal to 1 billion Earths. And if we had super advanced technology that could make the megastructure only 10 kilometers thick, we'd need about 1 million Earths worth of material to build it. A significant problem is that our solar system only contains about 100 Earths worth of solid material, so our advanced alien civilization would need to dismantle all the planets in 10,000 planetary systems and transport the material to the star to build their Dyson sphere. To do it with the material available in a single system, each part of the megastructure could only be 1 meter thick. This is assuming they use all the elements available in a planetary system. If they needed, say, lots of carbon to make their structures, then we're looking at dismantling millions of planetary systems to get hold of it. Now, I'm not saying a super advanced alien civilization couldn't do this, but it is one hell of a job. I'd also strongly suspect that by the time a civilization got to the point of having the ability to build a Dyson sphere, they'd have a better way of getting power than using a star, if they really needed it. I have no idea how, but they are a super advanced civilization. Maybe I'm wrong, but it can't hurt to look.